What if I told you that the same chips that power Fortnite and Call of Duty also power ChatGPT, self-driving cars, and even military simulations?
Gosh, bow down! Bow down to Booga! Ladies and gentlemen, there's no way anyone beats him! Your Fortnite World Champion, Booga!
Behind all of this is a single company, Nvidia.
This is what hundreds of millions of gamers in the world plays on. It's a GeForce.
In the 1990s, it was just a scrappy startup fighting to survive against 70 rivals. Today, it's worth over $1 trillion, controls 80% of the AI chip market, and is so powerful that governments now fight over its products like oil.
Well, Nvidia has set a record on Wall Street. The chip maker is the first company to pass $4 trillion in market value. This makes Nvidia the world's most valuable company, surpassing Microsoft and Apple.
So how did Nvidia go from nearly bankrupt to eating the entire world? Let's find out. Nvidia was founded in 1993 by three men: Jensen Huang, a Taiwanese immigrant with a background in electrical engineering, Chris Malachowski, a chip designer from Sun Microsystems, and Curtis Prim, an expert in computer graphics. They started the company with a simple but risky idea: graphics would be the next big thing in computing. Back then, this was far from obvious. The early 90s were full of hardware startups chasing the promise of 3D graphics. More than 70 companies were competing in the space. Giants like Intel and 3DFX were already pouring resources into the same race. For a small startup with limited funding, survival seemed almost impossible. Nvidia's very first product, the NV1, was a very ambitious product. It combined graphics, audio, and a Sega Saturn gamepad port into a single chip. But this do-it-all approach backfired. The NV1's architecture used quadratic texture mapping, while the rest of the industry was moving toward triangles as the standard for 3D graphics. Developers didn't want to rewrite their engines for Nvidia's unusual design, which meant poor software support, resulting in poor sales. Their second attempt, the RIVA 128 in 1997, finally began to turn things around. Unlike the NV1, the RIVA 128 embraced industry standards, making it far easier for developers to adopt. It was also faster and more cost-effective than many rivals. For the first time, Nvidia had a card that could compete head-to-head with established players like ATI and 3DFX. But their true breakthrough came in 1999 when Nvidia released the GeForce 256, which they branded as the world's first graphics processing unit. By integrating hardware transform and lighting, the GeForce enabled far more realistic 3D environments without overloading the CPU. Priced at around $299 to $349, the GeForce hit a sweet spot, affordable enough for PC gamers, but powerful enough to feel like a massive leap forward. The GeForce 256 quickly became one of the best-selling graphics cards of its generation. But while Nvidia was rising, almost all of its competitors were falling. 3DFX, once the king of PC gaming with its voodoo cards, collapsed after trying to manufacture its own boards instead of just making chips. Nvidia undercut them with faster, cheaper GeForce GPUs. By 2000, 3DFX was bankrupt, and Nvidia swooped in to acquire its assets. S3 Graphics, which was dominant in 2D graphics, became a laughingstock in 3D graphics. Their Verge card was so slow it was nicknamed the 3D Decelerator. They faded into irrelevance. Matrox, known for sharp image quality, couldn't compete on raw performance and retreated into niche markets. Even Silicon Graphics, once the titan of high-end 3D workstations, missed the consumer GPU wave and collapsed. Ironically, many of STI's top engineers would join Nvidia. By 2002, the once crowded field of 70 companies had narrowed down to essentially just two: Nvidia and ATI. Everyone else was either dead, absorbed, or irrelevant. Nvidia had firmly established itself as the king of gaming graphics. But Jensen Huang wasn't satisfied with just making video game graphics cards. He saw something even bigger. In 2006, Nvidia unveiled a platform called CUDA, short for Compute Unified Device Architecture. At its core, CUDA was a way to let developers use Nvidia GPUs for general purpose computing. Instead of a GPU just drawing pixels on a screen, CUDA let programmers tap into its thousands of cores for tasks like physics simulations, financial modeling, or protein folding. At the time, this was a bit of a radical move because it was known industry-wide that if you wanted real computing power, you used a CPU from Intel or maybe a supercomputer. But Jensen Huang had a different vision. It was a risky bet. CUDA required developers to learn new tools and rethink how they programmed. For years, adoption was slow. But in 2012, everything changed. That year, a group of researchers at the University of Toronto, led by Jeffrey Hinton, Ilya Sutskever, and Alex Krivitsky, entered an image recognition competition called ImageNet. Their model, AlexNet, was a deep neural network trained on millions of images. The problem they had to deal with was training a model that big on CPUs would have taken weeks, so they turned to Nvidia's GPUs running CUDA. This yielded great results. AlexNet crushed the competition. It was a breakthrough that shocked the AI community. Suddenly, researchers in natural language processing, robotics, and speech recognition all started using Nvidia hardware. And because CUDA was proprietary, Nvidia had vendor lock-in. Once researchers wrote their code for CUDA, it was hard to switch to anything else. This created a feedback loop. More developers using CUDA meant more tools built around Nvidia, which meant more researchers and companies choosing Nvidia GPUs. Then came ChatGPT. When OpenAI launched ChatGPT in late 2022, it became the fastest growing consumer product in history, hitting 100 million users in just 2 months. By 2025, billions of queries are being handled by AI models every single day. Behind the scenes, all of these run on tens of thousands of Nvidia GPUs. OpenAI's GPT-4 model alone is estimated to have required over 25,000 Nvidia A100 GPUs to train. Microsoft's Azure, Google Cloud, and Amazon Web Services have spent billions buying Nvidia's hardware just to keep up with demand. And the money pouring into AI has been staggering. In 2019, global AI investment was around $40 billion. By 2023, it had exploded to $189 billion, nearly a five-fold increase. For Nvidia, this was a once-in-a-lifetime windfall. In just 5 years, its data center revenue jumped from under $3 billion in 2018 to over $47 billion in 2023. Its stock price skyrocketed, resulting in Nvidia becoming a $1 trillion company. It was clear AI was the future of computing, and where there's a gold rush, there are always competitors trying to grab a share of the mine. Intel, the king of CPUs, tried to muscle into the AI chip space with acquisitions like Habana Labs. AMD, Nvidia's old gaming rival, launched its MI series accelerators and tried to undercut Nvidia on price. And perhaps most threatening of all, Google developed its own chips, the Tensor Processing Unit. All of these challenges had the resources to topple Nvidia, but none of them have, because Nvidia had something far more valuable than raw silicon. It had an ecosystem lock-in. Nvidia had spent more than a decade building CUDA and a massive library of software tools, drivers, and optimizations that developers relied on. AMD and Intel may sell fast chips, but they can't sell the ecosystem that Nvidia has. As a result, by 2023, Nvidia controlled more than 80% of the AI accelerator market. That means 4 out of every 5 AI chips sold worldwide were Nvidia's. Nvidia could have stopped at gaming and AI chips, but Jensen Huang had bigger plans. He wanted to turn Nvidia into the operating system of AI. One of the boldest bets came with self-driving cars. Nvidia launched Drive, a platform that gives vehicles the computing power to perceive their surroundings, plan routes, and make split-second driving decisions. Today, companies from Mercedes-Benz to Tesla suppliers use Nvidia's chips and software as the brains of their automation fleets. But Nvidia's ambitions go far beyond the road. In 2021, it unveiled the Omniverse, a virtual simulation platform that some have called the metaverse for engineers. With Omniverse, companies can design factories, test robots, or train AI systems inside a perfect digital simulation before deploying them in the real world. BMW, for example, uses Omniverse to design and optimize its production lines, cutting years of developer time. Step by step, Nvidia has expanded its reach into nearly every sector of the global economy. And with AI accelerating, its influence is only growing stronger. Essentially, the world now runs on Nvidia. The unique and powerful position of Nvidia also made it geopolitically important. The same GPUs that power video games also drive the most advanced AI models in the world, and more importantly, military simulations and cyber defense systems. That's why in 2022, Washington imposed export bans on Nvidia's most advanced AI chips, blocking them from being sold to China. The fear was that China could use Nvidia's technology to accelerate its AI capabilities in defense, surveillance, and next-generation weapons. This made Nvidia one of the most important geopolitical chess pieces at the American government's disposal. Nvidia's rise has been meteoric. From a scrappy startup fighting to survive in the 1990s to a company shaping the balance of global power, Jensen Huang's gamble on GPUs created a technology so essential that nations now fight over it, building one of the most valuable companies in the world, from gaming graphics to global power broker. That's how Nvidia ate the world. Thank you for watching.